Okay, next we're going to look at solving inequalities with absolute values. And there's sort of two interpretations of this that I think are both helpful. So we're going to be looking at inequalities such as like absolute value of x is less than, let's say, 3. So one way to interpret this is by looking at our graph. Okay, so the absolute value here is our y value. We want to know when y is less than 3. So for what x is absolute value of x less than 3. All right, so our answer is going to be just an interval of x values. And if we take a look at our graph here and we draw in the line y equals 3, we are interested in where our y values are less than this, smaller than this line. Okay. And so I'm going to just draw on top of the graph first, but then underneath that we'll draw the corresponding x values. We're going to be smaller than this throughout this v. Okay. And so what that corresponds to is this domain. So we're actually equal to 3 at -3 and at 3. So the solutions here are going to be a single interval, -3 to 3. Another way of thinking about this is with a distance formula. So in this interpretation, we're saying we're trying to solve the same inequality. So solve absolute value of x is less than 3. So that means, again, find x values that satisfy this. But what we're going to be thinking about this, the way that we're going to think about this is with a distance formula. So this is saying that the distance of x to 0 is less than 3. Okay. All right, and so that means if we go out to 3 and down to -3, these are sort of the extremes. Every x value of between -3 and 3 is strictly closer to 0 than that. Okay. Right, so we're saying start at 0, go 3 to the left, go 3 to the right, everything in between there is going to be a solution. Okay, and so in general, when we see the absolute value of x is less than or equal to a, we're always going to be able to rewrite this as -a less than or equal to x less than or equal to a. This is going to be a single interval. Solution. Okay. So for example, if we know that absolute value of x is less than or equal to 2, then our solution is -2 less than or equal to x less than or equal to 2, which we might also write as -2 to 2. Okay. So we're taking this value here, where we're this provides an upper bound, and then the negative of it provides a lower bound for our interval. Okay. Next up, we're going to look at this case where x is greater than or equal to a. I'm going to just take a moment and redraw these pictures. Okay, and we're going to think through the same sort of problem, just with the inequalities direction reversed. So we're going to look at x greater than or equal to a. In this case, why don't we make it real specific and say x greater than or equal to 3. Okay. All right, so our first interpretation, again, this is our y value. Okay. So we're going to be thinking about reading off where our y values are bigger than or equal to 3. I'm going to draw in a line at y equals 3. And then looking this over, we're going to first highlight where the graph has y values greater than or equal to 3. And then the actual solutions here are going to just be the x values. So we're solving this. That is, we're finding the x values where that holds. And so we want to know when our y values are 3 or bigger. We see that they are sort of at the tail end of this absolute value. Okay, and if we draw this out, here we were allowing equality. We actually see two different intervals where this holds. So we're going to have solutions negative infinity to negative 3, union 3 to infinity. And another way that we'll write this is x greater than or equal to 3 and x less than or equal to negative 3. Because no x value can be in both negative, less than negative 3 and more than positive 3, our solution set is going to use the word or here. All right, let's also look at this with a distance interpretation. So we're asking for the x values. So find x where the distance to 0 is greater than or equal to 3. And sort of similar thinking, we go 3 to the right and 3 to the left. And everything that is more than this is going to be further away than 3. Everything that is less than negative 3 is going to be a distance 3 or more from 0. So here we have two intervals. And so the way that we break down an absolute value inequality, like absolute value of x is greater than or equal to a, is that we're going to rewrite it as x less than or equal to negative a or x greater than or equal to a. All right. So let's do one example of that. If we want to solve absolute value of x is greater than 5, then this is the same thing as saying x is less than negative 5 or x is greater than 5. All right. So when we go to solve an absolute value inequality, what we're going to do is get our absolute value all on its own. Then we're going to expand our absolute value inequality, rewriting based off of the direction of our inequality. If it's less than, then we are going, if the absolute value is less than a value, we'll have a single interval, negative a less than x less than a, single interval. Or if we have absolute value of x is greater than a, then we will have two intervals, x less than negative a or x greater than a. And then we will solve each of these inequalities for x. So let's try this out with a couple of examples.